So the next one's a little bit busier. The next one asks us to find the derivative of the natural log of the quotient x plus 1 over the square root of x minus 2. So here we'll be using the chain rule and also the quotient rule. Again, we could think about this as the composition of two functions. The outermost function is going to be my natural log function. The innermost function is going to be my quotient of x plus 1 divided by the square root of x minus 2. And if I'm differentiating, I'll be using the chain rule derivative again. So the derivative of my outermost function, the natural log of x, simply is 1 over x. So I'll have my 1 over x. But instead of using x, I'll be using my original argument, my x plus 1 over the square root of x minus 2. And then I'll be taking the derivative of my original argument. And this requires the quotient rule. And that's why this problem is kind of busy, because it requires all these elements. So in the quotient rule, I'll take the function on the bottom, my square root of x minus 2, times the derivative of the top. The derivative of the top is simply 1, minus the top, x plus 1, times the derivative of the bottom here. This guy's derivative is requires also the chain rule, and it will be equal to 1 over 2 square root x minus 2. And on the bottom, I'll have my bottom function squared, so I'll have the square root of x minus 2 quantity squared. Now we got to simplify. And that's usually what makes things kind of tough here, but I'm going to show you a little trick to sort of get around that. And the trick is to look at the denominator and think about rewriting all those pieces as fractions. First of all, this guy here up front, it's 1 over a ratio. So, you know, when you have 1 over a over b, you can write that as b over a, just using properties of fractions. So immediately we can write that as the square root of x minus 2 over x plus 1. For the numerator up here, I'm going to write this as the square root of x minus 2 divided by 1. You'll see y over 1 in just a second. Minus, and when I'm looking at the product of these two functions, I'm going to write it as a fraction. So in this fraction, I'm going to have my x plus 1 in the numerator, and in the denominator, I'll have 2 square root x minus 2, and all of that is going to be divided by the square root of x minus 2 squared, but when we square root, they cancel each other out to give me simply x minus 2. Now notice that in this numerator, I have two fractions that I can add the old-fashioned way by considering their LCDs. Their LCD is 2 square root of x minus 2. So what I'm going to do is just copy all of this here and introduce a special value there to add the two fractions together. So what I'm going to do is multiply the top and the bottom of this term by 2 radical x minus 2. So now I have two terms that have the same denominator, and I can add them the old-fashioned way, just adding fractions. So this is the square root of x minus 2 over x plus 1 times, when I multiply these two terms together, the square root of x minus 2 times the square root of x minus 2 is simply x minus 2. And when I multiply by 2, I will have 2x minus 4. Let me give myself more space here. And this will be over 2 radical x minus 2. For this guy here, I'm going to take the negative sign out front and distribute it through to both of these terms to get negative x minus 1 over 2 radical x minus 2. And the denominator will stay as x minus 2. Notice that these terms up on the numerator now have the same denominator, so I can add them together and get the square root of x minus 2 over x plus 1 times x minus 5 over 2 radical x minus 2 over x minus 2. We could simplify this. First of all, this term here is something that looks like a divided by b all divided by c. And a nice property of arithmetic says that this is equal to a over b times c. So I'll be able to take that term and write it as x minus 5 divided by x minus 2 times 2 radical x minus 2. Here, these two radicals cancel out completely, and I'm left with x minus 5, let's put that 2 all the way in the front here, times x plus 1, x minus 2. Whew. Now, that was a little busy. It wasn't the easiest problem. But now I would like to redo this problem and use some of the properties of logarithms to show you the benefit of working with logarithms. Let's differentiate the same function. So let's say we take this, copy it, and attack the same problem, but before we start taking derivatives, let's apply some properties of logarithms first. Recall that whenever you have the logarithm applied to a quotient, like let's say a over b, this is going to be equal to the difference of two logarithms. This is equal to the natural log of a minus the natural log of b. Also, whenever we have a logarithm of an element raised to a power, we can rewrite this as the power times the log applied to a. And in particular, if we're looking at something like the natural log of the square root of a, well, another way of seeing the natural log of the square root of a would be as the natural log of a raised to the power of 1/2. Then we could take the 1/2, put it all the way in the front, and then simply compute the natural log of a. So we'll be using these three properties to tackle that derivative in a much easier way. So suppose we're looking at the function natural log of x plus 1 divided by the square root of x minus 2. Before I differentiate, I'm going to use these properties and take this natural log function and decouple it as the natural log of x plus 1 minus the natural log of the square root of x minus 2. Also, this natural log of the square root of x minus 2 using this property can be written as 1/2 natural log of x minus 2. So if you're trying to differentiate the natural log of x plus 1 over the square root of x minus 2, you would get the same thing if you would differentiate the natural log of x plus 1 minus 1/2 natural log x minus 2. And that function is a lot easier to differentiate. So your derivative of natural log of x plus 1 is simply going to be 1 over x plus 1 times the general derivative of 1. Here's a minus 1/2, and the derivative of natural log x minus 2 is simply going to be 1 over x minus 2. Done. If I were to take this function and simplify it, we would get x minus 5 over 2 x plus 1 x minus 2. But we got there a whole lot easier using the properties of logarithms.